Okay, good morning class and welcome back to Math 11, Finance and Workplace. Last day we did a review of Pythagoras' theorem and I gave you an assignment to work on right angle triangles and figuring out the unknown sides. Today we're going to start looking at trigonometry again. I've already introduced this in prior years, so what we're going to do is review your knowledge, your background knowledge of the right angle trig rules, some of the lingo, the words, the names that we use for the functions in trigonometry, the basic trig ratios. SOHCAHTOA is a good acronym to remember, and I'll review those. They refer to sine, cosine, and tangent. So today we're going to be looking at the wording, how we name these things, and the basic ratios. So on your pickup box or in your website or pickup, you'll find the name Math 110. 110. Just go back and write it down. And today would be Trig, getting started. Okay, so every place we look, we do have right angles. If you just look around your room in here, every time you look at a corner of a room, you'll see that where the two sides come together, the angle between them is a right angle. That means the angle between the two sides is 90 degrees. That's what the definition of a right angle is. And a right angle triangle has one of those sides, or one of those angles, that's 90 degrees. Now, where would you use math and trigonometry? What kind of jobs? People were asking me just recently, where do we need math? Well, if we think about it, math gets you involved not just with money, because if you're working in the banks or with working with taxes and that, yes, you need to know about math. But if you ever see those people working on the side of the road when they're fixing the highways, you'll notice that they have little transits up. They're looking through it just like a telescope. Well, these people are surveyors, and they're trying to find out what the angles are of elevation on the road, so they know where to put in places where you have to cut down the road to make it level, especially when they're building railroads. You can't put a railroad track up the side of a mountain because it takes too much work to drive the train up there, so they have to cut down the land to make it level or put a tunnel through a mountain. So surveyors have to come in and make sure it's level. When they built the channel from England, there is an underwater tunnel that cars can drive through in order to make sure that, and they started it, one in England and one over in France, and this was all water, and they went underneath the water and they started building a tunnel, and they went this way. They both started at the same time, and they had to meet at the exact same spot. So they had to be very, very correct in their calculations to make sure that when they met, they would have the same big hole would be in both places. Another type of place that we use trig all the time is when we're trying to build something. Carpenters, building anything that uses lumber or steel, we have to connect them, we have to know the lengths, we have to know the angles. So we use trig all the time as well. Carpenters use it to build steps. Engineers use it to find the distance across the river. You can find the distance across the river without actually crossing it. If you have a river here and you want to know how far that is between the two, what you can do, say you want to know how far it is from here to here, you got something that you can know, say it's a house or a building you can recognize, and you want to know how far across it is. Well, if you're standing here, all you do is go down the shore, measure that distance, say it's 100 feet, and you look right across to where you want to go. You measure that angle. You know this distance. You can use trig to find out what this part is. So once you know one side and one angle, you can always figure out another side and another angle. That's what's important, how important it becomes to use trig. It's used in geography and navigation. People on ships, the old days especially, they used to use the stars. They didn't have GPS satellites. They had to use the stars. Satellites are used now in outer space. The signals go back and forth to help us locate ourselves exactly. Astronomy is the people that study the stars. How do we know how far a star away is or what the distance between things is? They use trig. They use the distances to them and the angles between them to figure out how far they are and how big they are. And of course, in the military, if you are a person working in artillery and someone radios back and says, I want you to fire some shells over to the enemy, say this is where the cannon is over here, and you want to make sure that you get it to where the bad guys are, you've got to have the right angle. So if you don't, you might hit your own men. So you got to know exactly what angle to shoot that cannon at. So trig becomes very important in the military as well. Now, here's an example where someone had to think about trig. They were trying to fix something behind a house. They couldn't get around it. There's a work site behind the house. There was no way to bring the equipment behind the house, so they had to put the crane in the front. And in order to put materials back there, the crane would have to be able to lower something down this way here. So in order to decide what size of crane, to put the crane over on the street here, they would need to know how far the work site is away, and they would need to know at what angle the crane boom would have to be in order to start lowering, whether it's cement or materials, down. So you would need to know the distance from the street to the work site, and you would need to know what angle so you could clear the top of the roof here. You couldn't, push the crane through here. You'd have to push it over the top of the house and then lower it. So let's look at some of these examples of trig. You've worked them in the past in the language that we use. The reference angle. Whenever we're working with triangles, we know that we have three angles. One of them is 90 degrees. But we have to say, are we talking about this angle? Or are we talking about this angle? So whatever angle we refer to is called the reference angle. If I tell you that angle A is 60 degrees, then A is my reference angle. Okay? Reference angle is the angle that is being referred to. Which one am I referring to? The right angle, as we just said, is the angle that is 90 degrees. 90 degrees is going to be the right angle. Sorry, let's go back and move too fast. Angle that is 90 degrees right here is your right angle. Now, the other words we need to know are opposite side, hypotenuse, adjacent sides. So let's look at the first one, the opposite side. In a triangle, we're going to have three angles. We label the angles with uppercase letters, the capital letters. So this is reference angle A, angle B, and angle C. The side is always opposite the angle. So if I'm talking about angle A and side A, if I'm standing there, I look right across from it, it's here. And I write a small letter A for side A. For C, it's across from the right angle. For side B, it's opposite the B angle, and we use small letter B. Okay. So if I'm talking about side angle A, my side opposite is here. If I'm talking about angle B, the side opposite is here. You notice they're different sides. A is opposite A, B is opposite B. The hypotenuse. The hypotenuse. Hypotenuse is always the side that is opposite the right angle. So no matter which way your triangle is made, here is my right angle. The side that's opposite, the C side, is also called the hypotenuse. It's no Greek word. And one thing about the hypotenuse, it is always the longest side. It is always the longest side. So if I had measurements there, say this was 3, this was 4, well, this one would have to be 5. It would have to be bigger. I couldn't have this one as 2. That would be wrong, because 2 is smaller than 3 and 4, and hypotenuse always has to be bigger. Okay? Now, next is the adjacent side. Well, let's look at one of the reference angles. Say we are looking at angle A. Well, which is the opposite side? Over here, opposite. Which one is the hypotenuse? The hypotenuse is opposite the right angle, so it's over here. The next side, the only one left, is the one called the adjacent side. It is the one next to it. The word adjacent means standing next to. If you were to look to your side, that would be your adjacent side. So for angle A, this is the adjacent side. However, if I was looking at angle B, this would be the opposite side for B, and this one would be the adjacent side for B. But they both have the same hypotenuse. The hypotenuse cannot be changed. Any questions so far? Okay. And then finally, we look at the meaning of SOHCAHTOA. So what we've got so far is a reference angle. We have an opposite side. So if this is the reference angle, the opposite side would be here, opposite B. The adjacent side would be here. Okay. For angle B, that's the opposite side. This is the hypotenuse, and the side that's left over, the side next to the angle, is the adjacent. Where am I going to put it here? Well, remember the right angle's here. I'm looking for hypotenuse. So I put the hypotenuse right there. It's the longest side. The opposite side, this is my reference angle. A is the reference angle right now. A is the reference angle. So my opposite side would be over here. The opposite side to A is here. And then the last side, that side next to A, is adjacent down here. So if the reference angle changes, the sides change. The only one that stays the same is the hypotenuse. Okay. Let's try one more. Here's my reference angle. I always look for the hypotenuse first. So there's my right angle. My right angle is here. So I know that my hypotenuse will be opposite that. So I take my hypotenuse and I label it right there. That's my hypotenuse side right here. Then I look for the opposite side. The opposite side to B is down here. So my opposite side is down here. And the only side left, the one next to A, is right there. There's my adjacent side. Okay? Here's the angles, or the triangle's a little bit changed, but just look for the right angle. Here's the right angle, the 90-degree angle. Remember the side opposite that one is my hypotenuse. The hypotenuse is down here. If I'm looking for the opposite side to A, it would be here. And then my adjacent side would be over here. But now let's change the reference angle. I'm going to erase this. And now I'm going to use angle B. Now let me move my things away. This time, angle B will be my reference. My hypotenuse is still here. It hasn't moved. But now, my opposite side is over here. And then my adjacent side is the only one left, would be there. So depending on your reference angle, will determine where your opposite and adjacent side is. That's very important. Let's get to SOHCAHTOA. SOHCAHTOA. They refer to the sine ratio, the cosine ratio, and the tangent. Where do we get that from? Well, so the S stands for sine. The O stands for opposite, and the H stands for hypotenuse. So if we're trying to find the sine, now we usually just write it as S-I-N, like sin. Say it is an angle A, it will be OH, opposite over hypotenuse. Then I look at the second part, ka. That is cosine. So C is cosine. You write it as COS. A is A adjacent. And H, again, is hypotenuse. They're just abbreviations for each of the sides. So my cosine, I'll just write it. Remember, the A is the adjacent. Will be adjacent over hypotenuse. And then the last one in the trig ratios is TOA. TOA. So I say SOHCAHTOA. So TOA is tangent. TOA. That's tangent. I just write it as tan. O, again, is opposite. And this time, A adjacent. So I write tan equals opposite divided by adjacent. So there's our three trig ratios. And the way you can remember them is just remember the acronym SOHCAHTOA and write it down every time. Whenever I do trig questions, I write down I'll put it in black here. SOHCAHTOA. Toa. That name is memorized in my head, and then I can just put that at the top of my page, and then that helps me decide which trig ratio to use. Okay. So that's the memory aid, so Katoa. If we're given this angle, if we're given this side and this side. So this is my angle here. So I label my triangle first. That means this is the opposite side. And the other given is this. It's hypotenuse. So if I need to find out what this is, I can use Pythagoras, or I can say I need to find this. That is my adjacent side. Now I can choose any number of these things. If I know this and this and this angle, I can look for, okay, I need adjacent, but I have hypotenuse. I want to find this, want to find the adjacent. I'm given hypotenuse. I look up here, which one has AH? Not this one, but this one does. So that means I'm going to use cos. So I say, okay, cosine of A is equal to adjacent side over hypotenuse. If they tell me that angle is 60 degrees, say it's given, I write cosine of 60 degrees will equal, I don't know what adjacent side is, so I put an X. But I do know what the hypotenuse is, and so I would put a number, whatever that is, say it's 10. And then I would solve for that. I have an angle, a side, and I solve for the unknown. And we're going to go through examples of that just to make sure you know how to do it. So looking at our first example where we had our crane, say we know that the angle there that the crane boom has to go up is 63 degrees. We know that the length of the boom here is 101 feet. And we want to find out what this is. How far it is from the top to the bottom. Okay? That's a fire truck, and it's trying to reach up to this building. Wants to know how high that boom can go, which window can it reach to. So I'm given this, I'm given this. So I'm saying, all right, let's label that. Here, this is my opposite side. This is given. Remember, it's opposite the right angle. That's my hypotenuse. So I have hypotenuse. I'm looking for opposite. You go back to here. Which one is OH? It has to be sine. That's the only one. So I write sine of 63 degrees is equal to opposite, I don't know. My hypotenuse is 101 feet. And then I solve. So anything, we have this, we can put it over 1. If you remember, we can cross multiply. 1 times x is x equals sine 63 times 101. So then we got to go to our calculator. And we need a scientific calculator. And we see here our scientific calculator has sine, cosine, and tan. So the first thing we do is we have to put in our sine 63. And we have to multiply it by, oh, this calculator, sorry, it all varies, but we have to put the 63 in first. Okay. 63 degrees sine times 101 feet. 101 equals. And there we have our answer, 89.99. So I would round that off. 89.99, I can round that off to 90 feet. So that means that this distance here would be 90 feet. You could go up. That fireman could raise his ladder and reach up to the window that's 90 feet above the ground. Okay? Okay, we're just going to go to your unit assignment here. I'm going to give you the handout to the people here at the TC. They can get it on their pickup box as well. People at home, you will go to your teacher pages website at BHS, the Transition Center, and you will see the assignment 1, Trig getting started, and I want you to complete just these questions here, 5B, 6B, 7A, and so on, 10B. Complete them and hand them in by Monday, 3 o'clock. You want me to go through one more example? I'll just go back a couple slides. Let's see when that's given here. All right, we have the same situation here. This time, we know that the height from A down to C here is 90 feet. We know that this length here is 101 feet, but they want us to find the angle. What is going to be the angle? So, first thing we always have to do is label the triangle. So, if this is the angle I'm looking for, what is this side? Opposite. What is this side? Opposite the right angle, so that's your hypotenuse. So again, we have opposite over hypotenuse. Opposite OH, you have to use sine. So this time, I don't know the angle, so I use this symbol. Just a circle with a line through it. That means that's the angle we're looking for. Sine of theta, sine of the angle. Equals opposite over hypotenuse. That's our sine ratio. Then, sine, we put in the numbers. The opposite side we know is 90. And the hypotenuse is 101. If I divide 90 by 101, go to our calculator. 90 divided by 101. We got 0.89. Now we got to find out what angle that is. It should be a second function on this. Oh. We don't have one on this calculator. We'd have to use second function. You'll see a button on your calculator, 2ND, or sometimes it is shift. Okay, 2ND or shift. You press that key when you have that 8.91, all those numbers, and that will give you the angle. And the angle would come up would be 63. Would be 63 degrees. So look for the key on your calculator that says second or shift, and then you would hit sine 0.891 and so on, whatever those numbers are. For sine, if it was cosine, you would hit cosine. If it was tan, you hit tan, depending on whether you're looking for. This time we're looking for sine, so you use shift or second sine 0.891 and so on. Okay, so that's it. Just going back again, your assignment. Complete these problems for Monday afternoon. Thank you.